all around the world, there are buildings and structures in desperate need of demolition.
The bridge was designed in the 30s, so the bridge had served its useful life.
I'm Brendan Moore, self-confessed demolition junkie. In this series, I scour the globe in hunt of the biggest, most dangerous,
There really aren't too many safe ways of doing it.
and most spectacular demolitions I can find. My mission? To reveal the inner workings behind the art of demolition. To meet the experts.
Taking a building down of that height has to be done carefully.
And the machinery capable of levelling anything in their way.
A lot of science that goes into it. It's not just like the match and hold your ears and wait for the boom.
So I've flown 16,500 kilometres from Sydney, Australia to Manchester, and it has not disappointed, given that it has the reputation of being one of the wettest cities in Britain.
Located in the northwest of England, Manchester is also one of Britain's largest cities. It's home to one of the world's most popular football teams, the 36-mile-long Manchester Ship Canal, and a thriving university steeped in history. Originally built in the 19th century, the university's older buildings are quite magnificent. Some of its newer structures, though, are due for an upgrade, like this ugly great monster of a bridge. And that's great news for demolition diehards like me. Whenever there's some serious building bashing to do, I'm going to be there. So I've travelled halfway around the world to see this giant concrete eyesore reduced to a pile of rubble. Built in the 1970s to connect the university with the business school next door, this unusually wide structure is more than just a walkway, containing shops and restaurants too. Now 46 years on, the shops have been emptied, and this concrete colossus has finally had its day. And as I always say, what goes up must come down. "36 metres long and 21 metres wide, this bridge is a 6,000-tonne monster. Keeping this behemoth up requires some intense reinforcement. Running through the bridge are 38 concrete beams kept in place by thousands of metres of highly pressurised steel tension cable. The structure is essentially a wire suspension bridge coated in concrete. It was built to hold up more than double its own weight. That means 120,000 people could gather on top of it and it wouldn't budge. A bridge with that sort of strength isn't going to come down without a fight. This is one of the trickiest and potentially most disastrous demolitions I've set my eyes on. The bridge is wedged between two buildings, including the precinct library. To make matters worse, this is one of the busiest commuter routes in Europe. Because of this, explosives aren't an option, and the risk of bringing down half the street is very real.
The only way you're going to get something like that on the ground is by having brains, some big machinery, and a solid plan.
And the man with the plan on this job is Paul Johnson. A demolition veteran of over 30 years, if anyone can get this bridge on the ground quickly, it's him and his men.
This is vital now. Has to happen now.
Even for a crack demolition team like this, it's going to be a difficult job, and one full of massive risks. It's still dark outside, but the team starts work at first light, and they're making last-minute preparations nearby.
So keep this really simple for me. How is that bridge coming down tomorrow? How are you going to do it?
It's 6,000 tonne of concrete up here, sandwiched in between a deaf centre, shops and the university library. What we've got to do this job is 3 50-tonne excavators fitted with concrete pulverisers, very specialised equipment. We've got a 55-tonne excavator with a 7-tonne pulveriser, like a giant pair of concrete scissors, and we've got to crunch it down.
This extremely treacherous demolition has 3 main phases. Phase 1, start crushing the beams that support the bridge. There's no turning back once this is underway, and from here on in, anything could happen. Phase 2, and this is by far the riskiest. Remove the supports that attach the bridge to the buildings either side. Any mistakes made here and the university's library could end up as a pile of rubble in the street. Phase 3, the make or break moment when we smash through the remaining beams and pray they come down without dragging anything else with them. If it goes wrong, it could spell catastrophe for us all. Project manager Nick Parkinson is acutely aware of the dangers they face.
We have to be really careful because these bridge beams touch buildings either side of the road. We need to make sure that we take down the concrete roof and the bridge beams and make sure we get it down into the road without disturbing the buildings either side.
To complete all 3 phases without causing serious damage and get the road open again is no mean feat. And they don't have much time.
How long do you think it's going to take to get this down?
We're hopeful we'll get it down in 15 hours.
I think he's being a bit optimistic. I think it's more likely to be an hour every beam because we've got bits of steel to take out above, we've got the roof to take in, and we've got the sides and the diaphragm beam to tidy up. I think we'll be finished Sunday lunchtime with the bridge on the deck.
Okay.
Nick's forgetting one thing. I've got gravity on my side.
Paul's schedule is ambitious, but if 10 months of extensive planning is to pay off, then the first few hours are going to be critical.
It's 6:30 in the morning, half an hour in, and already we're starting to see that progress. Like 2 concrete munching brontosaurus, we've got machines eating into the bridge from both sides. By sunset, we're going to see all of that bridge down on the ground, or so they think. I'm going to go see Paul and Nick and see how they're getting on. Morning, Nick.
Morning, Brendan.
This weather's a bit better this morning.
A lot better this morning, yeah.
Okay, are we exactly where we need to be at this point?
We started off about half an hour later than we wanted to start off, but things are going well, yeah.
So what are we doing right now?
Well, we got one machine with the cruncher, pulling pieces off and pulling the concrete off. And we've got the pecker pecking at the beam and making holes in the beam to try and de-stress the beam. The concrete just falls away and we're just going to be left with the steel and that'll sag down.
So you're effectively taking the meat off the skeleton, and the skeleton is then too weak to support itself.
Yeah, absolutely.
Phase 1 is in full swing. The aptly named Muncher and Hammer are a monstrous mechanical tag team. Ripping a bridge like this apart requires a combination of incredible force and uncompromising precision.
How quickly do you need to get through each one of those beams to stay on track?
If Paul's going to be right, it's going to be finished today. He needs to do one every half an hour. So I think, you know, one every 40 minutes, 50 minutes.
Pulverizing concrete on this scale creates a big problem for the team on the ground: dust. To keep us all from choking on it, the bridge needs to be constantly doused with water. It makes an already difficult job much harder and much more dangerous. The team work hard to stay on schedule and protect the surrounding structures, but they soon hit their first major challenge.
Concrete beams got massive retention steel stretched to full capacity. That's what keeps the bridge up. We brought the concrete off it. That relieves the tension a bit. Otherwise, it can explode the concrete.
The cables are the backbone of the bridge, taking the weight of all 6,000 tonnes. Cut under tension, all pressure held on the steel would be released at once, whipping the cables out with incredible force.
We cut one end, we're relieving that tension, it'll explode.
Right.
For For the next few minutes, the success of the whole project relies on the steady hand of the expert cutters.
You've got to be so careful. The power in that is excessive. The attachment you've got up there weighs 7.5 tons. The machine weighs 65 tons. What we can't have is an uncontrolled collapse.
The tension begins to come out of the cables, but we must make sure we don't cut too early. If the cable's cut while still taut, it'll blast out of the bridge, showering us all with huge lumps of concrete.
That one came off perfect, that. Just the plan.
It's taken much longer than expected, but it's a relief to have got through the first beam's tension cables. They're going to have to pick up the pace if they're to get back on schedule though, and the biggest nightmares of this job are still to come. As they push forward, I'm off to meet the man tasked with filling the hole we're going to leave behind once this bridge is confined to history. James Birkin is the university's architect.
So what's it going to look like?
Amazing.
Of course it is.
The project as a whole is the redevelopment of the Manchester Business School, which is part of the university. The building is going to look a lot different from what it is now. The bridge is, as it currently stands, well, prior to demolition, it was quite a dark, uneventful space, quite intimidating, really. We want to drive this building forward, and we want to push the vision forward and the aspirations of the business school and the university. It really is a new gateway to the Oxford Road corridor down to the university.
And even those in the business of new builds appreciate the beauty of a top-class demolition.
It's a complicated structure that's there, and it's, as we can see, it's quite well made. It's putting up a lot of resistance to the machinery that's there trying to break through it. You're picking pieces apart. You can't just go into a piece of structure and snip at it or crunch it away or knock it down, because it will always have a consequence on the remaining structure that's there, on the environment around it. So there's quite a lot of respect for the demolition team. They're under a lot of pressure to get it demolished on time.
I'm back on site and the guys are still tearing through the bridge.
As things have moved on, we know how the beams are reacting now, and the lads are sped up.
So how many beams in are we?
We've done 10 beams on this side, and we're just a little bit further behind on the other side with 7 beams.
This means we're fast approaching phase 2, removing the diaphragm beams and praying that we don't take a few librarians with us.
Each of those diaphragm beams weighs 500 tons.
How do you make sure that you don't do any damage to those buildings?
The 2 diaphragm beams are floating. You don't put any lateral pressure on. You free them, break them out.
The diaphragm beams connect the bridge to the buildings on either side. These have to be removed before the remaining central beams are pulled down. Else they could collapse too soon, pulling the buildings down with them. Before the team tackle this critical part of the job, Paul calls a break in proceedings so they can plan their next steps carefully. It looks more like a war zone than a university around here now, just the way we demolition junkies like it.
After 12 hours of so much noise and so much carry-on and so much dust, it's beautiful to have this quiet. And you know what? Just counting through the beams, they've done pretty well. They started with 36 beams. They're now down to 6 left. That calculates, after 12 hours, that's pretty much 1 beam every 25 minutes. That means that those 6 beams should come down in the next 3 hours. 12 plus 3 is 15. 15 hours is precisely what Paul said it was going to come down in. But he's still got the side beams running down the side.
The time for talking over, the team roll nervously back onto the site.
We're in the thick of it now. The real thick of it.
How important is it you keep the focus now?
We've all got got to keep our focus. The two guys driving these machines, Ian and Robert, are excellent guys. They're focused. This is a big responsibility. It's not for the faint-hearted.
The machine operators have to detach the diaphragm beams from above. Any sideways pressure could cause the collapse of the wall they're attached to. I can feel the tension around the site. It's hard to watch. This could go either way.
Here we go.
One beam down, one to go. But there's a problem. The second one's not budging. It's been severed from the rest of the bridge, but hasn't collapsed. If in some way it's still attached to the building and fell uncontrollably, then we could end up demolishing more than we bargained for. It looks like the hammer's going to need a helping hand.
Here we go.
Beautiful work. Textbook.
Looked to me like there was a lot happening very quickly there.
There was a lot happening very quickly.
Yeah.
We've come to the critical phase of the job. And the diaphragm beams come off okay. We've not done any damage. There's time yet.
Did they come off just as you wanted them to?
Absolutely perfect.
Perfect.
Always going to be a difficult job. You're pulling a lump off that weighs 125 tonne. Absolutely perfect. Let's go and have a look at this beam. Look at the size of these, Brendan. High tensile steel. These were under pressure like that. They were keeping those bridge beams tight. That's what held the bridge up. Not much of a bridge now though, is it?
So far, so good. The buildings are still standing. One man who hopes they'll remain that way is Peter Huxley, who works in the bookshop located right underneath the bridge.
What's it like for you today, seeing this bridge come down?
It's going to be a huge improvement. It's been pretty grey under that bridge. I can tell you, our front door's under the bridge, and it's a pretty miserable place. It was a bit of a monstrosity, and it's going to look a lot better without it. On Monday morning, if it's a sunny day, it's going to be a shock to the system for us. Yeah, it's going to look very, very different. The mystery was how they were going to do it. There were stories they were going to blow it up, you know, they were going to take it away section by section, and here we can see that just smashing it to pieces. That seems to be the answer.
Smashing it to pieces. Do you know what a detailed plan this is that these guys are adhering to?
From this position, it looks like smashing it to pieces to me.
If only it were that simple. But if Peter's bookstore is still going to be there on Monday, this wrecking crew need to stick to the plan. Diaphragm beams destroyed, we're moving into phase 3. Nerves of steel required now. The last few beams need to be removed, which could spell the end of the job, or if they're in any way supporting the buildings either side, it could spell disaster.
It's 10 past 8 on day one, we're losing the light, and we are that close from our breakthrough moment. For the first time, you can really see those 4 machines coming together. They're 2 beams away, and man, it has been so much work, and I think everyone's getting a little bit tired and cannot wait for this moment.
With the light fading fast and the clock ticking, no one knows if pulling down these last few beams might trigger the complete collapse of everything around us. Two beams quickly become one, and as they chip away at the final piece of this incredible demolition, For the first time, we can literally see the light at the end of the tunnel. The success of this entire job comes down to one man and one super strength piece of machinery. It's a staggering achievement, but there's still one important question.
What time is it, Nick?
20 past 9, Paul.
I said it'd take me 15 hours. That's 15 hours and 20 minutes.
You said 15 hours.
Yeah, but we had a brew.
Well done, Paul.
Thanks, Nick, mate.
Well
Thank
done.
you, thank you.
Absolutely. Top notch.
But it's all these lads who did it. All these lads who did it.
The guys have a lot to be proud of. In just 15 hours, they've demolished one of the widest bridges I've ever come across, in one of the most complicated demolitions I've ever been on.
All's well that ends well. That's what I say. And it's ended well. That bridge is in that street. A few tricky moments. I was always a bit bothered about the diaphragm beam. I was bothered about crashing the library wall in, which was occupied on Monday morning. But if I told everybody, all me insecurities, we'd never get anything done, would we? We've got over every obstacle on this project. Busiest busway in Europe. 6,000 tonne of concrete on it now. So that's the next job. We'll clean up after ourselves.
It's been an exhausting but impressive day's work for the boys, but the job's not quite over yet. When you've made a mess, you've got to clean it up.
Start cutting this wire. Road's got to be clear. Drivers need to know where they're going.
For Paul, the job won't be over until every last bit of the bridge is cleared up and shipped out.
So it's the morning after the night before. How's the tired factor?
There will be no white flag over this door. There will be no retreat and no surrender. Keep going till the end of the road. And we've got to get to that end of the road, then we can go.
It might look like a pile of rubble to me and you, but for Paul and his company, it's all valuable salvage.
All the wire in that bridge, all the reinforcing, all going to a recycling station. I see 6,000 tonnes of recyclable concrete, and there's about 200 tonnes of steel with about £20,000.
Nice, nice.
The concrete will be used to build new roads, while the steel will be melted down and sold, making Paul and his team a tidy profit. In my opinion, the job's been a huge success, but I've not been on a demolition yet where lessons haven't been learnt.
Would you have done it differently?
Yeah, there's one thing I should have done, and that's get them to give me more money.
Well, Paul, maybe that's going to happen on the next job.
Who knows?
Yeah. Very good to meet you.
You too, buddy.
See you in the next one?
Yeah.
Okay.
Locking and rolling.
So in just 15 and a half hours, they have removed a bridge that has stood for 46 years. No explosives, no dynamite, just some nice big machines and a bit of planning.
Six weeks on, and the bridge is a distant memory. The road is reopened to the public, and Peter's bookshop is still standing. See you next time. All around the world, there are buildings and structures in desperate need of demolition.
The bridge was designed in the 30s, so the bridge had served its useful life.
I'm Brendan Moore, self-confessed demolition junkie. In this series, I scour the globe in hunt of the biggest, most dangerous,
There really aren't too many safe ways of doing it.
and most spectacular demolitions I can find. My mission? To reveal the inner workings behind the art of demolition. To meet the experts
Taking a building down of that height has to be done carefully.
and the machinery capable of levelling anything in their way.
A lot of science that goes into it. It's not just light the match and hold your ears and wait for the boom.
To me, every demolition is a work of art, but implosions are the real masterpieces. Everybody, including myself, appreciates the excitement of something being blown up and seconds later being reduced to rubble. But actually, the most fascinating part of an implosion is what goes on behind the scenes.
And that's precisely why in this episode, we're visiting the United States of America, specifically a town called Alexandria in the southern state of Louisiana. Alexandria lies in the center of the state. Home to around 50,000 people, it's a busy city with a heritage in cotton farming and historic links to the US Air Force. Situated on the banks of the Red River that cuts across Louisiana, the city is a busy thoroughfare, linking the south of the state with the north. With so much traffic, it's not surprising that local infrastructure needs regular redesigning and updating.
You guessed it, that means bringing in the demolition experts to clear space for the new roads and structures.
The latest highlight of all that delicious destruction is this monster of a bridge. Until recently, the OK Allen Bridge carried nearly 40,000 cars a day over the river. But it's an old design built with old materials, and it's time we helped it into retirement.
But no job of this magnitude is going to be easy. It'll require some serious manpower, the ingenuity of an experienced team, and always some luck. Oh, and one more thing, a whole lot of explosives.
As the fate of an entire road network hangs in the balance, top officials from the Department of Transportation and Development are on site too. No one appreciates the importance of bridges in the area more than they do.
There are 13,000 bridges in the state of Louisiana. Our geographic makeup is so vastly different from any other state in the United States. The many rivers that we have flowing through here, swamps, lakes, so many different type of wetlands that are incorporated here in the state. So we have quite a few bridges. DOTD, we're responsible for inspecting all 13,000 bridges across the state. We've invested over $1 billion into just our bridges alone.
The OK Allen Bridge was built 79 years ago. It's had a good run, but it's starting to show its age and is no longer a practical route for the people of Alexandria.
The OK Allen Bridge, it was completed in 1936. It was built during the administration of Governor OK Allen, Oscar K. Allen. He died the same year that the bridge was opened. He died in January of 1936, and the bridge opened later that year. This bridge was narrow and kind of scary for some people to cross. It was kind of frightening to them because it was so narrow, and an 18-wheeler would be coming the other way. People would go out of their way to not go over the OK Allen Bridge because it was too traumatic for them.
Design flaws aside, the bridge posed a serious threat to the safety of the thousands of commuters that crossed it each day, and so eventually was closed to the public.
The bridge was designed in the 30s and is not capable of carrying the loads that we have today on our highways. Plus, it was also pretty narrow. Only had 11-foot lanes, and we only had 13 feet of vertical clearance, and that caused us some problems with maintenance and keeping the bridge in service. So the bridge had served its useful life.
The two-lane bridge nowadays is not adequate given the capacity of the roadway. Freight loads going across our highways these days are much heavier than they used to be in the past. So the decision was made to widen it from a two-lane roadway to a four-lane roadway.
The disruption caused by the closure of this vital link over the Red River to neighbouring Pineville would have been catastrophic to the flow of the local highways. So the OK Allen's replacement was built before it closed just meters away, and all traffic is now diverted across the new Curtis Coleman Bridge.
It's a major corridor right here through central Louisiana.
The new bridge had to be close to the old one, so it could connect to the existing highways. But that causes a major headache for our demolishers and their explosive experts. How do you blow up a huge steel structure like this old bridge without firing huge twisted chunks of metal, travelling hundreds of miles an hour over the surrounding area and risk bringing the brand new bridge down too? You can't just strap dynamite to the bridge and hope for the best. Months of preparation were required to get the bridge ready for demolition.
Because of the length and weight of the bridge, it couldn't be removed in just one simple piece.
Before the team could even think of blowing this bridge into the history books, all of the concrete was removed piece by piece to expose the steel skeleton below.
It was a long, slow process. It's taken 6 months or more, but most of the structure has been removed. All that remains right now is the superstructure over the river itself between the two piers, and that, of course, is what we hope to bring down with explosives tomorrow.
It's the day before the demolition, and the explosives are being carefully placed onto the steel frame. With so much at stake, Deirdre and her team have to ensure all angles are covered.
We're communicating with everyone involved, the contractors as well as law enforcement, and we believe we have everything in place to where we expect a successful outcome once the demolition of the bridge occurs.
But with all the planning in the world, demolitions like these will always be dangerous jobs.
A bridge of this size, length, and weight, there really aren't too many safe ways of doing it. With any kind of blasting procedure, there are dangers involved. There's a possibility that some of the explosive devices won't go off, and therefore the bridge won't go anywhere. And there's a possibility that some of the charges might go off, and if some of them don't, if that causes the bridge to lean to a certain side, there is that possibility that it could hit the new bridge.
With so much that could go wrong, the team are taking no chances with public safety.
So what we're going to do is close the road off to traffic and clear the area. We get it all clear, then we can start our inspection of the new bridge, make sure it is safe for passage of the public.
They're working to a tight deadline. Not only do they need to reopen the new bridge as quickly as possible to limit disruption, the debris also needs to be removed from the river. Local authorities are involved to make sure the operation runs smoothly.
We still have fishermen, we still have commercial traffic that go up and down the river every day. Once the bridge actually enters the water, this portion of the river is actually closed to all boating traffic until they get that debris out. Now the engineers, they have a permit that lasts for 72 hours, so within the 72 hours they have to have that bridge totally clear of the river. So all the debris has to be removed in 72 hours.
But for now, the team have an implosion to get right. A bridge this large needs an equally large quantity of explosives. I wanted to find out more about how this explosion was being designed and what impact the blast could have on other structures around them. So I'm meeting with John Woodward, a demolition consultant and explosives expert.
Hi, Brendan.
G'day, John.
Nice to see you.
How would the demolition team at Louisiana have arrived at the decision to use explosives in this instance?
It depends on the structure, where the structure sits, and really the fabric of the building itself. It's a steel structure, so it lends itself to explosives. I think the difficulty with the bridge, one, it's spanning the river, so it's difficult then to put machines onto the bridge. It's designed in a particular way with an arch, which means that as you start to remove the arch, then the strength of the bridge itself is removed. So very difficult to put machines on the bridge. From my point of view, explosives is certainly the best way to deal with a structure like that.
Okay, how are the charges going to bring a bridge like that down?
They're going to place charges on the arch itself and on the bridge deck. Those are going to be on the junction points. They have to be precise to cut it into the sections that they require. We use various types of explosives depending on the structure that we're going to demolish. They'll be using cutting charges. And a cutting charge is basically a small section of copper which heats up to tremendous temperature, cuts through the steel like a knife through butter, which then creates a small gap where the charge was, which then allows the rest of the structure to start to move into the gap, and then gravity will bring it down and drop it in the river. The key thing is to make sure that they've done everything possible, because once you start the initiation, there's nothing else they can do about it after that point.
But even if the charges go off as planned, a shockwave from the explosion could have disastrous consequences.
Describe to me what a shockwave is.
The best way I can describe a shockwave is
It's air being expelled away from the charge. What they would be concerned about on the bridge is that because of the fact they need to get the bridge down quickly, the explosives are going to go off in a sequence that is quite quick. And if you just imagine, it then pushes a large blast of air away from each of the charges. What impact is that large amount of air pushing rapidly sideways? How's it going to affect the existing bridge?
Is there any way of controlling shockwaves?
The only real way we can do it is the timing of the blast. If all the charges went off together, you'd have a very large area of air being pushed away in all directions, which means that possibly could unseat the bridge from the bearings next door. So what they will do is they will determine that when the charges go off, rather than one large charge going off, a number of smaller charges fractionally after one another. So you have a set of smaller waves going out rather than one large.
Timing on this implosion is critical. Blow the charges at exactly the same moment and the combined shockwave could damage the new bridge. Too far apart and the bridge could fall the wrong way.
There's a lot of preparation required, several months, to bring to fruition a few seconds of an implosion.
Do you ever get nervous?
Yeah, I think we do. If you're not nervous, then really you're too confident. It is a science, but you're also using things which you cannot 100% guarantee. Explosives are all slightly different. So from our point of view, once we initiate the explosives, there's nothing we can do after that. Just a normal day at the office.
The amount of variables that could affect this implosion are staggering. Even a cloudy day could have catastrophic consequences.
Whenever a shockwave goes off of an explosion, it's going to go out in every direction. Even though the charge itself is directional, when it goes off, it still has a shockwave that comes off of it that's going to go 360 degrees. It's going to go up, it's going to go out, and as it reaches up into our atmosphere, when it reaches cloud cover and things like that, it's going to reflect off of those clouds. It'll bounce back off. It can bounce off of buildings and that sort of thing. You would think it goes in a short distance, but actually it keeps on going and going and going until it dissipates. So on a nice clear day, that shock wave, when it goes up and out, it's going to go out and kind of dissipate. But if it has anything to reflect off of, such as cloud cover and things like that, then that cloud cover is going to refocus that shock wave and send it in another direction. There's a whole lot of science that goes into it. It's not just like the match and hold your ears and wait for the boom. So you have to take all those things into consideration whenever you're doing this to keep the public safe, as well as making the bridge do exactly what they want it to do.
Fingers crossed the weather improves tomorrow, or this bridge might not be going anywhere. It's 7 a.m. Despite all the potential problems, it's now or never for this demolition. Thankfully, the skies are clear, but a change in the weather could still throw months of planning out the window. The charges have been painstakingly placed, triple-checked, and detonators attached. Everyone begins to move into position. A crowd of onlookers has gathered, which provides an additional problem for the men on the ground, trying to ensure everybody's safety.
So many people are out here ready to witness this historic event. You've got people in boats, you've even got helicopters out here who are basically hovering above, trying to get footage of this moment in time, this moment in history. We're working with law enforcement agencies from all across the state. They are making sure that the waterway is secure so that no boats, no barges, or anything of that nature will try to come through as we're preparing for the blast to take place.
Blowing up a bridge is a very exciting thing for many people to come from all over to see it, and that's our biggest concern. We certainly don't want anyone within the blast zone.
As far as the actual perimeter for the safety blast, they've designated 1,500 feet as the perimeter around it, so they're going to make sure that no one is in that immediate area, and then we have a secondary perimeter on the outside of that. So we have deputies stationed up in different locations to where the public can actually get to, and as well as our traffic. We still have traffic control, so we stop the traffic outside those perimeters, and we have to reroute that traffic in different directions. Public safety, of course, is out front, and so if there's anything that's going to cause an extra danger to the public, then we're going to postpone it, because if anything goes wrong, it could be for a major catastrophe.
The traffic has been halted on the new bridge. As congestion begins to build, It's time to level the OK Allen so things can get moving again quickly. The 1 minute horn blows. There's no turning back now. At this point, all the team can do is look on and hope that 1 split second in time isn't going to result in months of repair work to the new bridge.
I'm feeling just really, really anxious. The OK Allen Truss Bridge has been a scenic icon for this area for so many years, for decades. A piece of history that's basically going to be gone within a matter of milliseconds.
It's pretty amazing.
This is it. Boom time. Any second now, the charges should go off and consign this bridge to the history books. The bridge drops, and at first glance, that looks like a textbook implosion. Undetectable to the human eye, the charges went off within milliseconds of each other as planned, and the bridge came down beautifully. The steel frame of the bridge becomes completely detached from its base, and because the explosives team managed to detonate every charge correctly, gravity does its job, and the structure just drops vertically into the river. Not a single piece flew off in any other direction. Once again, a truly remarkable achievement from the demolition engineers.
I shook because when it was like a delay, and so when I heard the boom, I was like...
That was one of the best things, coolest things I've seen in a long time. And I'm 77 years old.
It was badass. It's pretty cool. Never seen nothing like that.
But as impressive as that might have looked, and although they have successfully dropped a huge bridge straight into the Red River, the drama is far from over. Shockwaves emitted from the explosion could have damaged the new bridge, and this is damage that isn't easy to detect. At least not until 30 tons of traffic starts moving on it and things start to crumble beneath them.
The old bridge was about 100 feet away from the new bridge, so it was really close for a blast to take place. We have our bridge inspection teams out there. They are up on the bridge, inspecting the bridge, looking for any unintended effects to the new bridge.
They need to be able to view the bridge from every conceivable angle, so specialist equipment is brought in to help the engineers. Time is of the essence though. They have to get the road open as quickly as possible, but you can't hurry this job. If something is missed, it could spell disaster.
We're on a tight schedule because we want to minimize the amount of time that the bridge is out of service and not available for public use. So we are under a tight timeline. They all know that. We knew that when we planned the inspection to make sure that we did it as effectively, efficiently, and as thoroughly as we could. So we have a lot of pressure. Looking for impact points, any type of change in color of the steel or the concrete, looking for cracks, looking for chips, anything that might have blown against the bridge and created a crack, or any type of defect that would affect the structural carrying capacity of the member.
There's an equally pressing task going on under the bridge too. Part of the bridge's frame still remains attached to its concrete legs. It isn't safe for the cleanup crew to work directly underneath these, not until they've been tested to ensure they aren't about to come crashing down. If they aren't stable, it could significantly delay the process and possibly the reopening of the new bridge. So far, so good. Thankfully, it doesn't look like there's any immediate danger here, and the crew can push on. Now the hard work really begins. You can't just leave the debris of a huge bridge like this lying in the river, and the team move in to begin the giant clear-up.
In the 72 hours, they have to have that bridge totally clear of the river.
Each chunk of the bridge is extremely large, but was purposely blown up into manageable pieces, so the heavy-duty barges with cranes could pluck them out of the water. The barges can lift huge weights without toppling. That's some seriously impressive strength.
We will fish them out of the river, pull them out, load them onto a barge. They'll be brought to the bank, cut up into smaller pieces with hydraulic cutters, and then they'll be brought to a salvage yard.
No one likes to see the product of a good demolition go to waste. So once this metal is loaded up onto the trucks, it's going to be taken off and recycled. Meanwhile, the inspection team wait nervously while the final parts of the new bridge are checked. Only then will we know if this demolition has been successful or not. Even the slightest crack could put the new bridge out of action for months, spelling chaos for drivers in and around Alexandria.
We just got word that our inspectors have looked at all the major components. And everything is safe and just as it was before the blast went off. We have just cleaned the roadway of all the debris, and we are opening the road up and traffic is flowing on the roadway.
Destroying this bridge so successfully has been an incredible achievement for the team in Louisiana.
To control an explosion so precisely is nothing short of remarkable. There was so much that could have gone wrong, but somehow these guys pulled it off, and with some style too.
Implosions are the money shots in demolition, but only when they go well, and this one was a beauty.
Deirdre and her team couldn't be more pleased.
In the past 24 hours, we had this structure that's been there for years, and just to see that it was there yesterday, and just within milliseconds, it's now gone. It's pretty amazing.
The OK Allen Bridge is no more. She's down. After 79 years, the OK Allen Bridge is history.
It was a great day. Big piece of history gone. The bridge went just as planned. All the charges, we got to review the slow motion video, and so all the charges went exactly as they were planned. So everything worked out great. The blaster did a great job, and piece of history.
My hat's off to those guys. That's another amazing demolition, proving once again that there is as much skill and expertise in knocking things down as there is in building them up. Except in my opinion, you need a bigger pair of wrecking balls if you want to be in the demolition game. See you next time.